you get the next largest kind. Let's do that with our units. Picking them up, let's put them in. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we never count past 9, because what happens if I were to put 1 there? It would be just the same as 10. When we have 9 and we get 1 more, right here, 1 more, we have one of the next larger kind. We have 110. We can do that same thing with our 10s. Let's drop these out. 1, 2, 3, 4, 5, 6, 7, 8, 9. And what happens if I put 1 more in? That's just the same as 100. We never count past 9, because when we have 9 and we add 1 more, that gives us the next largest kind. In this case, 100. Let's use our tray and do something else. Now again, I'm starting out with it empty. With the younger children, it's nice to start out with it empty. That way there aren't a lot of distractions. I've put a 7 in. Can we build a 7 with a 6 and something else? Can you find the piece that will go with the 6 to build 7? Of course. It's a 1. And the tray is self-correcting. It's so easy for the child to succeed. Can you build a 7 with a 5 and something else? Right, a 5. And what will go here? A 2. Now, can you find a 4? And what can we put with 4 to build 7? A 3. Well, what if we start out with a 3? What would we put with a 3? The 4. Now let's try a 2. What could we put with a 2? That won't work. And you know what's going to happen? The child may pick it up and start to put it there, but immediately it's very obvious. It's visually obvious. This doesn't fit. They get it close. They put it away. They've corrected themselves. Now, they can build a 7 with a 2 and a 5. And what if we started out with a 1? What would we use? Let's see. I bet this will work this time. It does. Notice that here the child sees a 6 and a 1 and a 6. Both of them give them 7. Very important concepts for children to understand. If they have the experience first, then later when we attach fancy names such as the commutative property to that, it's going to mean a lot to them. Think about learning just about anything. I've done workshops where I talked to people before I ever went to that workshop. I was very familiar with their names. And in spite of the fact that there were 40 or 50 people at the workshop, it was very easy for me to call them by their name after just a few minutes, because I could attach the name that I had heard over and over again with that face. It's a lot different from walking into a workshop and not having ever met anyone before, or not ever having heard their name. When we know something, then just adding a little bit more makes it easier. Also notice that I use the word build. We can build a 7 with a 6 and a 1. That's a child's language. After you say that, then you can add those words plus and equals. Note 2. Let me write this. What does equals mean? Equals means the same as. Does this look the same? Now, be honest. Imagine being a young child. Does this look the same? No. But let's put the bars there. Here's a 4. Here's a 5. And here's a 9. Are they the same? Well, if we push them together, the child can see that it's the same quantity, it's the same length as, that these are the same. And you know what typically happens even before that? Children working with the blocks will discover that if they put a 2 with a 3, that's always 5. Always. It's pretty powerful when the child makes that discovery. Right now it seems minor to us, but take the time and think. That's very powerful for the child. Now you've played some games with addition facts, and I just gave you a sample, and I recommend that you look in your games and activities manual and find some other things. And let that games and activities manual be a starting point for your imagination. Here we have addition facts mastery. Let's look at it. Here we have a 1 with a 1. 1 plus 1 gives us 2. Here we have a 1 put together with a 2. 1 plus 2 gives us 3. Let's look at what the child is going to see. I'm looking at page 3 now. Here we have a 3. The child will fill in the 3 with a 1, and the answer is already filled in there. It's a 4. Here we see a 2 bar that we're going to get put together with a 2 bar. Now what's going to happen when the child gets out a 2 and a 2? Have them do that. Here's a 2 bar and another 2 bar, and a 2 bar and a 2 bar is the same as a 4 bar. And if they need to do that, have them do that. You see how they're going to have a lot of fun just filling in those problems. Now, if you look at page 7, here is a sample of some missing add-ins. What do I add to 2 to get 4? Well, here's a 4. Here's a 2. What do I put with that 2 to get 4? Well, it must be a 2. And below it, we have something that we put with a 2 to get a 5. Here's our 5. Here's our 2. And what do we put with that? We put a 3. So 3 plus 2 is the same as 5. Notice that the missing number changes position. Sometimes it's over here on the right, sometimes it's on the left, and sometimes it's in the middle. This is very important.